Our special guest today is Kurt Kelty, the Vice President of Battery and Sustainability at General Motors, and we're going to ask him all about new battery chemistries that are under development, the second life use for old batteries that they take out of EVs, and of course the way batteries will be installed in future electric vehicles. A whole lot of battery talk, but make sure you stick around for all that and a whole lot more right here on GreenCars, the podcast. Welcome! If you enjoy sustainable transportation, you are in the right place because that is exactly what we cover here on GreenCars, the podcast. I am automotive journalist Craig Cole, and I am joined by my co-host, the inimitable Sam Abuelsamid. He's also the Vice President of Market Research at Telemetry. And Sam, always great to see you. And you recently drove an interesting new Lexus.
Yeah, I got to go out to California to drive the new 2026 Lexus ES. You can never tell with the model years anymore.
Right.
They keep shifting when they're launching stuff. So yeah, it's a 2026 Lexus ES, which is an all new design. It's interestingly, it's available. They're all 100% electrified this year. You can get it either as a hybrid, like you could before with the previous generation ES, or you can get it as a battery electric. And the most affordable version of it is actually the battery electric one. It's cheaper than the hybrid.
How did they pull that off? That's like unheard of.
So they've got two variants, two electric variants. There's the ES350E and the ES500E. The 350E is a single motor front wheel drive version. The 500E is a dual motor all-wheel drive version. So the 500E is a little more expensive than the hybrid, and the 350E single motor is a little bit less expensive. And one of the interesting things about this car is that it's actually quite a bit larger than the previous generation ES. The ES is actually the last of the original Lexus nameplates from when they first launched back in 1989. They launched with the LS400 and the ES250 at that time. And the ES is the last one. The LS is gone now. And the ES now is almost the same size, actually slightly bigger than all but the most recent generation of LS. So it's about 6.5 inches longer than it was before, and a couple of inches wider and a little bit taller. And when I spoke with the chief engineer about why it got so much larger, what he told me was, because it's designed to be an EV, it's got the battery under the floor, which pushes the floor up a little bit higher, makes it a little bit taller than the previous generation was. And in order to maintain the proportions that they wanted, because it was now taller, it was going to have a taller roof, and they wanted to, have same or better interior space. They basically stretched everything else out to maintain the proportions they wanted, which made it LS size now. But it's a really nice car. Got some interesting design details. Both the hybrid and the EV are great. Although if I was buying one, I would probably buy the EV. Unless you really need, long distance and you just can't wait, half an hour to charge it. The EV, the front wheel drive version is 307 miles of range, about 290 for the all wheel drive version, which is really plenty for everybody. And it starts at $49,000 for the 350E EV, and goes up to a loaded dual motor EV will run you about $60,000.
That is very fair pricing for an electric luxury car that is almost Lexus LS sized. That's about half the price, or less than half the price of what the previous generation LS was. Wow. So it's a 2026 model year. It's got to be coming out pretty soon, I would think.
It's out now. The EVs are in dealerships now.
Nice.
They've been shipping for a couple of weeks now, and the hybrids are arriving in a few weeks, and so you can get them now as we're recording this, and by the time people are listening to this, they'll be readily available.
Does it look better in person than photos? I didn't think it was an unattractive vehicle in the pictures, but seeing it in the flesh, Sam, is it
Yeah.
better? Yeah.
Yeah, no, it definitely looks better. I mean, it's not, it's not it's not a wild design. It's a pretty, pretty straightforward design, but it's well executed.
Mm-hmm.
It's got the usual fantastic Lexus fit and finish.
Oh, yeah.
One detail that I really like in the EV version that you can't get in the hybrid is on the door panels and on the dashboard. You can get it with layered bamboo trim,
Oh,
which
yeah.
just looks
Yeah.
so good. It looks great. You can't get the bamboo on the hybrid for some reason, but you can get it in the EV. One other detail that's only on the EV is you can get the executive seating package in the back seats. So if you opt for the executive seating package, you get reclining rear seats, and on the right hand side, on the passenger side, there's an ottoman that comes up. So when you put down the center armrest, there's a touch screen there, so you can control the front passenger seat. You can move the front passenger seat all the way forward and pull up the ottoman, and you can just kick back and relax like you're in a business class seat.
Very nice. Very nice.
Yeah.
Our guest today, though, is Kurt Kelty, the Vice President of Battery and Sustainability at General Motors.
Yeah, so Kurt came to GM from Tesla, where he led battery engineering there for many years, and he oversees all of the battery research, development, manufacturing at General Motors. So his team includes the big battery lab that they have at the Warren Tech Center, all of the manufacturing, the various manufacturing plants, and so he's got his hands in everything battery related at GM.
Yeah, I would imagine so if he came from Tesla. But going forward, I would really like to learn about solid state batteries, what the status is of those. We've been hearing about them forever, but to my knowledge, there really aren't any in the market that have been commercialized.
Yeah, well, I mean, I remember back at CES in 2018, Henrik Fisker showing his latest vehicle that he was planning to produce. This is before they made the Ocean.
So many.
It was a luxury sedan, which he said we were going to launch it in 2020 with solid state batteries. Well, it's now 2026. Henrik Fisker's latest company is
Long
bankrupt
gone.
again and gone. That car never got built. Solid state batteries have yet to appear in any production vehicle. So we'll see what happens. We'll see what Kurt has to say about solid state.
Yeah, they're not quite ready for prime time, at least what I understand. We're going to ask him also about vehicle to home and vehicle to grid charging, because that's a potentially game-changing technology. And also some new battery chemistries potentially. So a lot of work going on in that area. And of course, we will welcome Kurt to the show here in just a second. But really quickly, for help finding your next ride, visit GreenCars.com, where we have expert reviews, a helpful buyer's guide, there's an EV matchmaker, and much more. Again, that's GreenCars.com, your hub for sustainable motoring. From the affordably priced Chevy Bolt to the sumptuous Cadillac Escalade IQ to the highly capable GMC Sierra EV, General Motors offers some absolutely fantastic electric vehicles. But helping them develop the next generation of EVs is Kurt Kelty. And welcome to the show today, Kurt.
Thank you. Happy to be here.
Yeah, so Sam's got some pretty technical questions for you here, but I figured as we dive into our discussion, we'd start off a little bit easier. So you guys just hosted what you called the Empower event out in San Francisco, a big deal for you guys. What was the news from that event, if you can give us an overview?
Yeah, it was a big event for us. What we announced there was our deepening entry into the ESS market. The energy storage system market. Until now, we've been addressing this market in other ways. Specifically, we've been using second-use battery packs and working with Redwood. Redwood then puts them into a system where they're all connected together. And we put in, it was about 50 megawatt hours about a year ago in Sparks, Nevada. They're backing up a Crusoe database. Data center. So we've been working with Redwood on that. We've actually got we're going to be backing up some of our factories. First one's going to be in Michigan that we'll be deploying it's going to be a smaller battery pack, but it's going to back up one of our factories here, and it'll save us about $3 million in total in our energy bills. So it's a real big savings in the long run, and we'll be deploying this in multiple factories as we go forward. So that's one prong of our strategy, and then another prong has been working with our partner LG. So we make LFP cells. Actually, we're about to start making them at our Ultium factory. So we announced this a couple months ago. These cells are going to be going into LG ESS systems. So that's so LG is the ultimate customer. We are manufacturing the LFP cells at the joint venture at Ultium for that. And what we announced last week was a further entry in that we're going to start working with Peak Energy. They're our partner, and we're going to be supplying them with cells. And the cells are going to be sodium ion cells. So that was a big change from the competitors out there. We're going to leapfrog the LFP chemistry and just go directly to sodium ion, and it's going to provide tremendous benefits out there. The biggest thing is we're going to get better cycle life, and the operating temperature range is more extreme on both ends. And the maintenance cost is lower. They operate passively, so you don't have to have a cooling system. There's just a number of benefits, and what it ends up leading to is you get a lower total cost of ownership. Now, that's what our customers are looking for. That's what they've been telling us. So it was a big announcement for us that we're getting into this business with Peak Energy, and we're super excited about it.
Yeah, lower costs. Everybody wants lower costs, no matter what industry you're in or where you live. But just to back up really quickly, the stationary energy storage, there's a lot of life that's left in an electric vehicle battery pack when it may not still be good for use in a vehicle, right? So you can repurpose those, refurbish them, recycle them, and use them for stationary storage, right?
Absolutely, and that's what we're doing in partnership with Redwood. Where we take these battery packs that, I mean, even if you've driven your car 150, 200,000 miles, there's still plenty of life left in the batteries. And so what we can do is put them in a second application, and they'll get several more years of use out of them. So it's the beauty of it. And then after that, the other nice thing about this is that they're then recycled afterwards. So Redwood takes care of the recycling. And what we're developing is a closed loop recycling system for our batteries, so that ultimately the nickel that goes into your batteries in the beginning comes out in the recycling stream and goes right back into the cathode material and goes right back into a battery and into a vehicle. So you get this continuous closed loop recycling. So that's what we're working on as well. So that's part of this whole process that we're the whole ecosystem that we're looking at.
Yeah, I understand that the first of those that you're going to be doing with Redwood for your factories, you're actually going to be using refurbished battery packs from the Chevy Bolts that were removed from the Chevy Bolts during the recall program a couple of years ago. Those are being refurbished, and you're using those for energy storage, right?
That's right, and so they've got lots of life left in them, as you can imagine. So they'll be out there for many years to come.
That's great. I mean, GM's actually got a long history with second life energy storage systems. Like going back early 2010s. They did one of the first ones at the Milford Proving Grounds using battery packs from the first generation Volt that were used in Volt development vehicles, and then taken out of those vehicles and used to make an energy storage system for some of your IT operations at Milford. Is that correct?
Yeah, there actually is a rich history here at GM in the EV space and ESS space. I mean, if you look at an EVs, I mean, with the EV1, we're the first producer coming out with a mass-produced EV. That was back in the early 90s. And then the Volt that you're referring to really was the first mass-produced plug-in hybrid. So it's we've got this history, and as you're bringing up right now, also developing this ESS system for our proving grounds was another breakthrough back then.
So I'd like to touch a little bit more on the sodium ion. That's actually something that's really new here. It's going to be one. Is that are you going to be producing those sodium ion cells in one of the existing Ultium factories, or where are those going to be produced?
So we're in the stage of development right now of these battery cells, and what we end up doing in terms of production, we don't need to make that decision, fortunately, for another year or so. So we're exploring multiple options for that at this point.
For context, sodium ion, what are the benefits or disadvantages of that versus, an NMC chemistry or an LFP chemistry that people may be more familiar with?
Yeah, so NMC, so the way that I kind of break it down is you have NMC is really the high energy density. That's what we've got in our Lyric packs and all of our vehicles right now is that NMC it's produced at Ultium domestically here, and that gets you the high range. Now, the other end you've got is LFP. So that's really the more affordable chemistry that's used in EVs today, really mainly in China. Less so here in North America. So those are the two chemistries, and we'll talk about LMR a little bit later, but I want to address your sodium ion question. Sodium ion, so LFP is kind of the low energy density, low cost chemistry, but sodium ion is actually lower than that, lower in energy density. Cost right now, kind of similar to LFP, a little higher than LFP. But it's actually lower energy density. So it's not appropriate today for use in vehicles. The
That was my next question, yeah.
It's just not there. You really don't want to go lower than LFP. So sodium ion, what it's good for is applications where energy density is less important, but cost is the overriding priority. So if you really need low cost, sodium ion is there. The other thing keep in mind is the big difference to LFP and sodium ion is the supply chain. So LFP, the supply chain it's designed for China, it seems like, where all of the raw materials that go into the precursor and it goes into the cathode material, they're byproducts of other processes in China. And so you've got this tremendous resource available at incredibly low cost in China. So LFP works really well if you're manufacturing cells in China. In the US, we don't have that fabulous resource available to us for various reasons. But the beauty of sodium ion is that we've got tremendous resources here available in the US. In fact, we're the largest, we've got more reserves than anybody else in the world here in the US. And it's incredibly cheap. It's very, very abundant. So the supply chain can be built up here domestically in the US much more readily than an LFP supply base. So you got multiple advantages on sodium ion. You got the supply base that works in your favor. You got cost that works in your favor. And then it's really that long cycle life and the operation at high temperature that really is the clinching factor here. That really, it hits all the performance metrics you need to get to in order to lower your total cost of ownership.
And of course, since an energy storage system doesn't actually have to move, size and weight isn't really the energy density isn't really an issue for something that's just going to be sitting there. Unlike in a car where you want it to be as small and light as you can for efficiency purposes in the vehicle.
That's absolutely right. There are some ESS applications where the space density is important, but the majority of ESS applications, they've got plenty of space.
Mm-hmm. So you mentioned that you're also going to be producing LFP cells at one of the Ultium plants to supply to LG. Are those essentially the same type of cells that LG is already producing at their plant in Holland, Michigan right now that they're using for energy storage?
I believe they're very similar to what's being produced in Holland. If they're exact or not, I don't know, but they're very similar to those.
All right. So something else that came out of the Empower event that I'd like to talk about a little bit was some of the work that's being done around vehicle to grid integration. Right now, GM, I think pretty much all of GM's EVs right now already support bidirectional capability. You've got a vehicle to home system to allow whole home backup from your EV if your power goes out. But now you're partnering with PG&E and I believe also DTE here in Michigan for to move towards vehicle to grid. Can you talk a little bit about what you're doing there?
Yeah, we've got some pilot programs set up with these utilities, and the beauty of V2G is that you've got a distributed energy source wherever you're driving your car. And if you connect to your house and if you want to take advantage of time of use pricing of energy, you can discharge into the grid at that point and then charge it up when energy's cheap. So it's a way to provide resiliency to the grid. So the utilities get tremendous benefit from this. So instead of building that last peaker plant at a very high cost, instead they can draw upon this distributed network of EVs that are connected to their system. So that are connected to the grid there. So it provides a great benefit for them, for the consumer. They can take advantage of the cost differential in electricity prices. So it ends up being a win-win for everybody involved.
So we see China obviously leading the world at this point, I think it's fair to say, in electric vehicles and related technologies. Do you think we're ever going to get there here in the United States? Or are we so far behind at this point?
Yeah, it's interesting what's happened in China. So remember, China didn't have a big ICE industry, the internal combustion engine, and so they kind of just leapfrogged the rest of the world and said, you know what, let's just go directly to EVs, and so that was really beneficial for them to be able to have that advantage to go directly there and really focus on that. They've gotten tremendous support from the government to enable adoption, and I mean, it's really impressive when you travel in China, the percent of vehicles that are EVs or plug-in hybrids or hybrids. Their market is evolving a little bit differently than the rest of the world. What's happened over the last year or two is the plug-in hybrid market has been taking off, but they're taking off with much bigger battery packs. So instead of in North America or in Europe, when you're talking about a plug-in hybrid, they go 40, 50 miles or so on electric, and then afterwards it's gas. But in China, they're doing 100, 200, 300 miles. I've even heard a 400-mile range with a plug-in hybrid, which just seems crazy. You've got a large battery pack. But the market's just different there. Their market, one of the big drivers for their market is when they take holidays during the year. There's the Chinese New Year's, and everybody takes holiday at the same exact time. And so you can imagine if you're an EV driver and you're going to drive somewhere, everybody else is driving at the same time, and you can't get access to chargers. And so that's why for them, a plug-in hybrid makes a lot of sense. Whereas in the States, here we generally take vacations at different times, and aside from Thanksgiving, there's a couple of days that are crowded at the charging network. But other than that, we usually have pretty good access to chargers, so we can go directly to EVs without having to use the plug-in hybrid as a stepping stone.
400 miles of range in a plug-in is crazy. I've never considered that even as an option. Normally it's like, 25 miles, 40 miles, whatever. 400 is nuts.
Yes.
Yeah. So, part of that you mentioned, with the growing popularity of plug-in hybrids in China is adoption of extended, what we call extended range EVs. And when the Volt first came out in 2010, it was marketed as an EREV, where it's primarily an electric vehicle. And only once the battery's depleted, it's always being driven by electricity. And then once the battery's depleted, then it would start the engine to keep the battery replenished. Is that part of is that one of the areas that you're looking at? Do you see that as a market as a technology for North America that we're likely to see more of in the coming years?
Yeah, one of the things that we've learned since entering the EV market is that there really are different segments within that market. There's a group of people that really like the plug-in hybrid. There's a group that really like the hybrid vehicles, and then of course is the EVs. we believe in the long term that the market is EVs. That's where we're going long term. But we also understand that it's not like you flip a switch and everyone's going to go to EVs. There is some transition that's going to have to take place. And plug-in hybrids are a really good transitional vehicle because as you were describing it, the Volt, it drove as an EV. When you got in it drove as an EV, and then at some point later on, when your battery was depleted, then you'd run off of the ICE at that point, and essentially through the electrical powertrain. So so we recognize that there are markets out there, and we're going to address them as appropriate, with the understanding that long term, we believe the future it's all about EVs and zero emission, not a little emission, zero emission. That's why you got to go for EVs for that.
With one of the interesting developments, again, especially in China, has been this shift in the architecture of the batteries, moving from kind of modular battery packs that everybody started with in the early 2010s, in part for safety reasons and also for serviceability. As you mentioned, the batteries last way longer than we thought they would, and still have so much life in them. So we're seeing adoption of architectures like cell to pack and cell to body architectures, especially with the LFP batteries. Is that also an area that the GM is taking a look at, to simplify the battery pack and again, reduce the cost by taking more and more parts out of it and having just the parts you actually need, the cells that are storing energy?
Yeah, no, I mean, you have to look at all that. And we've got, we've got in our basement in the building right next door to me, we've got probably 30 or 40 of our competitors' battery packs just torn apart. So we understand where the industry is going, and it really, really very well. And so we look at trying to optimize our own, our what we call the non-cell part of the battery pack. What we've done, the biggest thing that we're doing to enable the simplification of our battery packs is going to a prismatic cell. That prismatic form factor is just really critical. And just for the listeners on here, I mean, there's three different types. You can go cylindrical, you can go pouch, you can go prismatic. The prismatic one is the one that really enables these, whether you want to go cell to pack or directly on the vehicle, where you eliminate all the modules. I mean, you can do that because of the prismatic form factor. You mentioned LFP, but it's really not chemistry driven as much as form factor driven. And by using our prismatic cells, our current design, which is going to come up, which we'll release next. That one, we're reducing the module count by 75% compared to our current vehicles, and our part count is reduced about 50%. So we're able to really simplify things by going with these prismatic cells, larger cells, and making the chemistry, choosing a chemistry which is generally safer than some of the other chemistries. So you don't need as much non-cell materials within the battery pack.
To piggyback off your question, Sam, Kurt, what is cell to pack? What does cell to body mean?
Yeah, so it's all about eliminating more of the non-cell part of the battery pack. So cell to pack means you have a battery pack and you've got let's say you've got 100 cells and you line them up in that whole battery pack without a module. There's no separation. And one of the challenges with that, I hate to bring this up, a drawback to that because it's got so many benefits. But one of the drawbacks is if you want to refurbish it or recycle it, it gets a little challenging because these cells they need to be held in there somehow. And it's not a matter of switching out a cell and putting in another cell like you can with modules. Modules, you can take a module out and replace it. But the cell to pack in general is a design where the cells are fixed in position there. And if a cell is bad, the battery pack is bad. That's the drawback to it. The cell to body is you actually eliminate the battery pack altogether. And you're inserting the cells directly into the vehicle, which also makes it even more challenging if you want to do service of the battery pack or a replacement of it. It gets a little bit more challenging.
Because you
It
have
saves
cells
money
spread
up
about
front.
everywhere, right? Throughout a vehicle structure,
Well,
perhaps.
then no, they're all concentrated in the same space. You're not going to
You're not putting them in
spread
the
your
roof.
cells out all over. You're not putting them on. No, no,
As
no.
funny as that
It's
might
still
be.
one solid block. Yeah, it's still one solid block in the vehicle.
Yeah, I'd love to see an EV with the battery in the roof just for the horrifying top heaviness of the handling. I don't think you guys are going to do
No,
that.
your performance.
I think I'll pass on
Your
that.
Yeah, I don't want to see that. That performance would be terrible.
As long as we get a video of it crashing, then we can put it out.
Yeah,
Get a million views.
I mean, but you're bringing up one of the real advantages though of EVs is because the batteries are always in the middle of the vehicle, underneath the driver and the passenger. So your center of gravity is really low. So boy, good luck trying to flip an EV. The center of gravity is just too low. It's really hard to flip it. So it's another performance advantage of EVs.
Absolutely.
So you mentioned, you're transitioning towards prismatic cells away from pouch cells that you've been using up till now. A number of your competitors, most notably recently BMW, Rivian, are joining Tesla in adopting 46 millimeter cylindrical cells. And cylindrical cells traditionally have the advantage of being lower cost to produce because they're simpler. You roll up the electrodes and stuff it into a can and then weld it shut. I guess you can talk a little bit about, what are the upsides and downsides of prismatic versus especially a larger format cylindrical cell, and why perhaps you've chosen to go the prismatic route as opposed to the cylindrical.
Yeah, it's interesting. It seems like every OEM's got their own vision of what is most efficient, both from a cost and a performance standpoint. I spent 11 years at Tesla leading the battery team there. As you know, Tesla is cylindrical cells. That's what they do. When I was leading the team, we came up with the 2170 form factor, and it was perfect for what we needed it for. Where we are at GM is we're trying our best to optimize around the highest performance and the lowest cost. And in order to do that, the prismatic cell is generally considered the best solution. Now, there are places where cylindrical cells will be appropriate. So I don't want to second guess our competitors out there. Their cylindrical cells work best when the height matches the height of the cell really well. They'll make a difference if the vehicle is a really low profile vehicle. It could make sense. But if you're trying to really drive down cost, prismatic cells are just really hard to beat. And that's why we're going after this form factor, because we believe prismatic cells are the low cost winner out there. And if we can optimize the prismatic form factor so we get the height and the width to be optimized around our particular vehicle, then at that point, there's just no way you can beat it with any other form factor.
And I think, just to clarify, I think when you're talking about low cost, you're not just talking about the cost of the cell, because I think the cylindrical probably still has a little bit of an advantage at a cell cost level, but you're talking about the total system cost, everything that goes around that cell, the cooling, whatever sort of packaging you put around it, all of that put together is where you start to have the advantage.
Yes, I'm glad you're bringing that up. Yes, well, the way we look at it is you want to have the lowest dollar per watt hour at the pack level. It has whether the cost is expensive or cheap, it doesn't matter. It's the pack level that matters. And so what we're really doing is we're trying at GM, what we're doing is we're developing the right battery for the right application. And so in the past, we used the NMC chemistry in the Ultium factory. So we made one cell, one chemistry, one form factor, one module, and then we arranged these modules and a different number for certain vehicles, but it was all around a standard module. You can imagine we had limited capability to really change the design on vehicles because those modules were fixed. What we're doing going forward is we're designing each of the platforms around a particular cell, or you can put it the other way, we're designing a cell around that platform to really optimize the cell for that platform, both the chemistry and the form factor.
I want to touch on one more thing around the cell technology itself. One thing we haven't talked about so far is solid state cells. I know previously, GM has announced a partnership, I think, with SES on solid state lithium metal cells. What's the current status of solid state development, and when do you think that technology might find its way into high volume production?
Yeah, solid state's been, I've been hearing about it for over 20 years now in the business. And it's always been that chemistry of the future. It's still the chemistry of the future. The future is getting a little bit closer. But it's still, what we're focusing on really is more of the shorter term chemistries. What's going to get us in market within the next 5 years? That's the big focus we're on. So LMR is our main focus right now, getting that out to market. The silicon is behind is right behind that. And there's some other promising technologies out there as well that will get us both the higher energy and the lower cost. That's what we're looking for. Now, we're actively testing solid state. You can you can imagine all the big players, if you want to call them big, the startups that are working on solid state. They all want to come talk to us because we're number 2 market share in EVs. We're the big customer that they're targeting. So we've got a handful of these companies right now within GM that we're evaluating their technology. And if it eventually gets to the point where it can be commercialized, then we'll be moving full speed ahead on it. It's not there yet.
Yeah. What is what's holding that up? Is it the manufacturability? Is it the performance? The durability?
All the above,
Okay.
and cost, and cost. I'd add to it, but yeah, all of those.
Yeah,
Okay.
I was just going to say that solid state batteries sound a lot like hydrogen fuel cells. They're always about 10 years in the future, right? It's like, solid
Yeah.
state, it's coming out. It's coming. Fuel
Yeah.
cells, they're almost here. They're almost here. But
They've
they're
been
never
5
quite.
years into the future for at least the last 25 years.
Exactly.
Yeah,
Just to
right.
put you on the spot, what do you think would come out first? Be like a mass market solution, fuel cells or solid state batteries?
Or neither.
Or neither, right? Exactly.
No comment.
No comment. Fair enough. Fair enough. So, Kurt, you're the vice president of battery and sustainability at GM. You can probably have any vehicle you want in the portfolio. What are you driving these days?
Yeah, I was recently driving the Lyric, and then I've just recently changed to the Optic. They're very similar cars. The Lyric is a little bit larger than the Optic. They're both in the Cadillac family, and boy, they are fabulous cars. The ride and the handling of the vehicles are just they are unsurpassed. So I really enjoy driving these vehicles.
No Duramax diesel, though. I'm kidding.
You're not going to get me.
I'm just kidding.
Yeah.
Well, there are times, when you might need something like that.
Exactly.
If you need to, tow a house around, a Duramax diesel,
Yeah.
and a Silverado HD can be useful.
Yeah, literally a house.
Well, that is one of the beauties of what we've done here at GM is the number of vehicles, the number of options that we have available to customers. And we've got the small economical Bolt. And then we go all the way up to the big Silverado that gets 492 miles in a single charge. The torque on that is crazy. So you can tow whatever you want with that thing.
But Kurt, great discussion. Really quickly, before we let you go, though, we do a little segment toward the end of the podcast here. It's called 3 for the Road. We each answer a quick question. It's designed to help drivers go green. It's now the summertime. As a show note, we'll be taking a brief break around the 4th of July holiday, but don't worry, we will be coming back. But given that it's summer, it's also kind of like road trip season, so everybody wants to get out and go for a drive. So our 3 for the road question in this episode is, what is one destination that you've always wanted to take a road trip to, and could you get there in an EV?
Well, actually, so this weekend I'm flying to Jackson Hole, Wyoming, and boy, wouldn't that be nice to drive there? If I had a couple of days on either end, I would love to drive there and then continue on my way up through Yellowstone and Grand Tetons.
Oh, it's a beautiful area.
That would be fabulous.
Yeah.
Yeah, and if you've got our long range GM EV that's powering you, yeah, we could do that. There are chargers along the route that could enable you to do that whole trip. It would be that would be really, really fun. I'd certainly enjoy it, especially this time of year. It's got to be absolutely beautiful up there and cruising in a. I could see taking our Optic up there. That would be nice.
Or trade the Optic in for the Escalade IQ, get even more range.
Escalade IQ, yes, that would even be nicer. Yeah.
Hit the Super Cruise and go.
Oh, that's a great idea. Maybe next year.
Right. Sam, where would you like to go?
It's funny that you mentioned Wyoming, Kurt, because as we're recording this, about 24 hours from now, I will be hitting the road in an Escalade IQ. And by Sunday, we will be driving across Sunday and Monday. We will be driving across Wyoming and driving from Omaha. I'm driving from Michigan to Omaha, and then from Omaha on to Portland, Oregon, with a fleet of EVs, including an Escalade IQ, to move some rescue dogs. And so, as we started planning for this trip back about 6 months ago, I started doing some research. As you mentioned, there's the growth of the EV charging network, especially the fast charging network, has really exploded in the last couple of years across the U.S. Obviously your former employer, took the lead in that, but there's a lot of charging stations, including many that now have GM Energy labels on them that we will be using extensively throughout this trip. So really looking forward to this 2,700 mile trip across the country with an EV, driving in the Escalade IQ.
Yeah,
I'm totally jealous. Not only of the vehicle, but of the dogs as well. Sounds fabulous.
Yeah.
Yeah, doing a lot of great work there. That's a long drive, Sam. And of course, driving from Jackson Hole up through the Tetons to Yellowstone is a gorgeous area, no matter what time of year it is. Absolutely beautiful. My 3 for the road is a bit more cliche. I'd like to take an EV on Route 66. I think that would be really fun. Go from Chicago to Santa Monica. And I was looking at the PlugShare website the other day, and it looks like that shouldn't be a problem these days. Should be plenty of charging. I mean, it's a well-known route. People have driven it a lot, so that shouldn't be a problem. But Route 66, I think that'd be really cool to retrace in an electric vehicle. But Kurt Kelty, you're the Vice President of Battery and Sustainability at General Motors. Thank you so much for your time today. Fantastic discussion. Oh, that was really fun. Thank you for inviting me.
Thanks for your time, Kurt.
So what did we learn today, Sam? He had a fascinatingly candid answer when we asked him about solid state and hydrogen. I thought that was a really good response.
Yeah, compared, I think you asked him about hydrogen fuel cells versus solid state batteries. And, the story with hydrogen fuel cells is that they've been 5 years away for at least the last 25 years.
Yeah.
And it appears that the same thing is happening with solid state cells. There's a lot of hype around them. There's a bunch of startups that are working on solid state, a bunch of other automakers, Toyota, Nissan, Honda, are all doing a lot of work around solid state, but sounds like it's just not ready for prime time yet.
I mean, it's a big hurdle, a big technological hurdle to clear, because the battery is essentially a monolithic brick, right? And
yeah, it's got some fundamental differences on the inside of the cell, where you're storing the energy, and it's tough. Everybody is finding it hard to manufacture the solid state cells. A lot of companies have made small volumes of small solid state cells and even larger cells for testing in vehicles, but so far nobody has gotten to the point where they can manufacture a large format cell that you need for an EV and in high volumes, and also to make it last for the life of the vehicle. That's also
Mm.
another problem, is durability. So there's a bunch of different companies out there, many of which GM is working with. They're testing their cells, but just nothing that is ready yet to put into vehicles anytime soon.
What is ready, however, not for vehicles, but it sounds like GM is working with this right now, is the sodium ion chemistry for stationary energy storage systems, and that could be a game changer in a lot of ways as well.
Yeah, I mean, one of the beauties of sodium, for those don't remember their high school chemistry, sodium's kind of in the same part of the periodic table as lithium, so it has a lot of similar properties, and can be used for batteries in place of lithium. Uh, but one of the beauties of sodium is it is so readily available
Mm-hmm.
pretty much everywhere on the planet. It's one of the most common elements, and if you can use sodium instead of lithium, makes it a lot easier, a lot more cost effective to make batteries. We've seen some sodium ion batteries being introduced in China by CATL and some other companies. They have made some small volumes of some EVs in China with sodium ion batteries, but GM is really diving into this now, particularly with the energy storage market as a focus for them, and will be interesting to see when those arrive and how well they work.
Because it sounds like the sodium ion battery, it's not energy dense enough for powering a vehicle. Maybe in China they're just doing it as an experiment or
Yeah,
something, but this is really for energy storage.
yeah. So in China, the use cases have been for low cost, shorter range EVs. There's only a couple of models that have used the sodium ion batteries from CATL, and that lower energy density that you get from the sodium ion makes it less suitable for a vehicle. Because the batteries are going to be physically larger, and uh, you know that's a problem. In a vehicle, you want the battery to be as small and as light as you can make it, because that makes it, you get more efficiency out of the vehicle if you can reduce that weight. With the energy storage systems, though, those are basically, those are just sitting there.
Mm-hmm.
It doesn't really matter how heavy it is, and in most cases, if you're using it with a factory or a data center or something like that, the size and the weight is not really that important. As long as it's durable, then it's a great use case for it.
Mm-hmm. And of course, the other thing we learned about is GM reusing old battery packs from the Chevrolet Bolt, refurbishing and or recycling those again to use for stationary energy storage, which, there's a lot of life that's left in an electric vehicle battery pack, even if it's not good for use in an EV still, because the demands of the electric motor and driving take so much energy out of it. But stationary, right, the power draw just tends to be much less.
Yeah, I mean, even if you've got an EV that's gone, 100,000 miles plus, and maybe the battery capacity has dropped to 80% of its original capacity, you may not want to continue driving the vehicle with only 80 or 70% of
Mm-hmm.
its original storage range. But for again, for a stationary storage application, that's still a lot of battery that you can use. And GM happens to be in the position where, for better or worse, they had to pull tens of thousands of battery packs out of Chevy Bolts a few years ago
Mm-hmm.
for a recall. Those battery packs were removed from the vehicles. Vehicles got new batteries, and the ones that were removed, they've refurbished those, and they're working with redwood materials to turn those into energy storage systems that GM will use with some of its factories.
Yeah. And one other thing that Kurt mentioned I found absolutely fascinating was the state of plug-in hybrids in China, where he mentioned some of them have 400 miles of range for just a plug-in hybrid, which to us in the US is kind of crazy because normally you're getting 25, maybe 45 miles. That's really getting up there. But 400 miles is unheard of. But as he explained, it gets down to the different use cases, right? Here in the U.S., we don't all take vacation at the same time. Where in China, they tend to all be off nationwide. So that puts a different demand on the charging infrastructure and the fueling infrastructure. So an EV, a plug-in with 400 miles of range, makes more sense than it does here. But that's something I was completely unaware of, Sam.
Yeah, I mean, most of them, to be fair, most of them are not 400 miles of range.
Yeah.
I mean, in most cases, you're talking about 100 to 150 miles of electric range, which again is more than almost anybody needs on a daily basis. So if you have the ability to plug in at home, if you've got 150 miles of range or even 100 miles of range, you're going to be able to drive it without using any gas. And then for some of the higher priced, higher end vehicles, they're getting into that 300-400 miles of electric range with these vehicles. And you said, when everybody has got the Chinese New Year week off, or some of the other holiday periods, and they're all traveling at the same time, being able to use public charging at those times can be a little problematic. So having a small engine tied to a generator as a range extender for those cases allows you to continue using that. You've got a vehicle that 50 weeks out of the year is just a straight up EV. And then on those few occasions when you actually need to go longer distances at the same time as a billion other people, now you have the ability to do that.
Yeah, very interesting. But Sam, sir, appreciate your expertise and time as always.
My pleasure, Craig. It's always fun to talk to you and to our guests.
Yeah, another great show. And with that, thank you all so much for watching GreenCars, the podcast, right here on YouTube. Now, the audio version of this show is, of course, available from all of your favorite podcast providers. Also, make sure you subscribe to our channel here for more great content just like this. And next, click the link on screen to check out our fantastic discussion with Vidya Rajagopalan. She's the Senior Vice President of Electrical Hardware at Rivian. It was an enjoyable, and I'll tell you, very informative discussion. But again, thanks so much for watching, and make sure you keep it clean and go green.